Okay, so the other way to solve systems is called the substitution method. This is not going to be very popular with you because it is going to involve some work. However, we will need to practice it. We'll need to be familiar with it and just really understand that you can do substitution with solving systems. Okay, as always, make sure you're raising your hand and asking for help if you need help during this. It's a little bit more work involved, like I just said, but again, we're going to have to be able to do some work sometimes. Okay, this is not on your notes, but you should be able to do this. The solution for which inequality is not represented by the following graph. So this says that x is greater than or equal to -5. X is greater than and equal to -5. So if we were to solve these for x, for a, if you were to multiply both sides by -5, because you want x to be positive. So remember, when you have negative x divided by 5, you can apply the negative to the 5. So -5, x being divided by -5, if you multiply both sides by -5, this would be x is less than or equal. So it's not, oh wait, we switch, if we multiply by a negative, we flip the sign. So it would be x is greater than or equal. So A is correct. So we're looking for the one that's not. Again, you have a negative x divided by 5. Is less than or equal, I don't know why it keeps disappearing. So if we apply the negative to the 5 and we multiply both sides by -5, this number will be much bigger. So this is not represented by the graph. If we divide both sides in B by -9, we would flip the symbol, and so x would be greater than or equal to -5, so B works. If we divide both sides here by 2.5, -12.5 divided by 2.5 is -5. So the correct answer for this problem is going to be C. That was a little tricky, but you do need to remember that you have to flip the signs. If you were to do this in Desmos, you could put x is greater than or equal to -5 and look at how it's shaded, and then plug in all of those other ones to see which one does not match your Desmos. Anyway, that was a tricky problem, but probably very similar to what you might see on your SOL. All right, so think about, in a recipe, why can we substitute margarine for butter? Think about that. Why can we substitute margarine for butter? So the answer is we can substitute margarine for butter because they're close enough to being the same thing. Might taste a little different, but butter and margarine, you can use those interchangeably. All right, so the notes, teachable notes here. To solve a system of equations using substitutions, number 1, you're going to replace one variable into the other equation, and that's called substitution. You're replacing one variable into the other equation. Remember, a system is 2 or more equations. In algebra, we'll only use 2. So you're replacing one variable into the other equation. Then you'll solve the equation for the remaining variable. And then finally, you'll replace the value in either equation to solve for the other variable. So there's a lot of words. Now let's demonstrate these words. Okay, there's 3 steps. In the next example, we're going to demonstrate these steps. So we have y equals 3x and x plus 2y equals negative 21. There's two equations there. Again, your more popular way is going to be to put those into Desmos. However, you are responsible for knowing and understanding the substitution method. How you do it on an SOL or a benchmark is up to you, but you are still responsible for knowing how to substitute. So we notice that y equals 3x. That's solved for y. So if we plug in what y is on the left, y is 3x. If we plug in 3x for the y, then we are replacing one variable into the other equation. We're taking that 3x and we're replacing it with, we're putting it into the y value. So we rewrite the second equation without the y. So we have x plus 2, and instead of y, we're putting 3x because y equals 3x on the left. Look at that. Before you say I don't understand, okay? If y equals 3x over here, and we take this 3x and we replace it, the y with the 3x there. We rewrite this entire equation without the y, but instead 3x. All right. Then it said to solve the equation for the remaining variable. We're solving this for x right here. Again, you can put that in Desmos and it'll give you what x is. Or you need to know how to solve an equation, so let's review it. 2 times 3x is 6x. So x plus 6x equals negative 21. Combine your like terms. You have x plus 6x is 7x. X is being multiplied by 7, so the inverse is divide by 7 on both sides. And you're going to get x equals negative 3. So now we know what x is, but we also need to know what the y. So we have half of our solution. We have the x value. So the last step is substitute the value in either equation to solve for the other variable. Well, I have x equals 3. I can sub it into here for this x, or I can put it here. Obviously, I'm going to put it into this equation because this has less work here. All right, I could put it in here, x plus 2y equals negative 21, or put negative 3 in for the x and solve for y here, or put negative 3 in for this x, and I'll get what y is. Either one, but I'm going to choose the easier one. Y equals 3x, and I'm replacing my x with a negative 3. So my y value is negative 9. So my solution is x is negative 3 and y is negative 9. All right, so this is where you would pause it, rewind it, listen to it again, or raise your hand so that I can come and explain what was going on here if you do not understand this. There are a few more examples that I'm going to go over, but I think you are going to practice the next two on your own. Okay, you are going to practice these two on your own, but if you need some more assistance, let's see, I'm going to do 2 more of the student examples on this video. So let's do student example 1 together. It's very similar to class example 1. We take the value for what y is, and y is 5x here, and we will replace it into the y in the other equation. And you rewrite it. You rewrite that equation, 2x plus 3. Instead of y, you're putting in parentheses 5x. You're going to distribute the 3 to the 5x, combine like terms, solve for x. And now you have your x. You have your x. So in order to find the y, you take that value for x and you plug it into either equation. I'm going to plug it into the first one, just less work there. So y equals 5 times 2. or y equals 10. Our solution is 210. So again, that's very similar to the class example 1. Let's look at another example together. So you're taking what x is 4y. This really only works when one of the variables is by itself. It could either be the x or the y, but you want one of the variables completely by itself and then substitute that into the other equation. So here, x equals 4y. All right, and you want to take that 4y and put it in for this x. When you rewrite it, it looks like this, and you only have y's here. Remember, you can put this into Desmos and get your y value, or you simplify. Distribute the 4 to the 4y, combine your like terms, do your inverse operations, and get your y value. Now, if we know that y is 5, we can replace it in either equation. It's going to be easier to put it into the smaller one. So x equals 4 times 5. Or x equals 20. And there's your solution in student example number 2. Now you will be doing student example 3 on your own. We will go over these, but you need to be trying them. If you need help, you need to raise your hand and ask for help. But again, we do need to practice these. So you have 3 to do on your own.